Alright, so we're back to max-min problems. I looked at the assignment. 4 people have turned it in so far. That's good. But I'm going to assign a few more problems. And let's make it due on Thursday. And again, I'll post it on Google Classroom. So the first example was a polynomial, so there was no corners in the graph, so the derivative was defined everywhere. Now we look at example 3 in the book. It's on that page there, 167. Here's x to the 2/3 power, and when you graph that, it has a corner, which means the derivative is undefined there. So in order to find this peak, we're going to have to determine algebraically where the derivative is undefined. Right, so you have to do 2 things. You have to take after you take the derivative, you have to set it equal to 0 and find where it's undefined. Okay, so take the derivative, set it equal to 0. So let's see, I added this to both sides, divided by 2, and now I have x to the negative 1/3. Negative exponent moves to the denominator, becomes positive. Multiply through by this denominator. Now to undo the 1/3 power, raise both sides to the 3rd power, because 1/3 times 3 is 1. And then 1 to the 3rd is 1. So x equals 1 is a critical value. So you either have a horizontal tangent line or you have a corner. Now if you go back, since this is where the derivative is equal to 0, I must have a horizontal tangent line. So that means that this guy right here, my graph's not to scale, but that must be at x equals 1, and there's the horizontal tangent line. Okay. Now, totally separate, go back and take the derivative and ask where it's undefined. Now, usually, to find undefined places, we're going to be working with fractions. So if I look at this derivative, this has the negative exponent. So if I move that to the denominator, I now have x to the 1/3 in the denominator. To make a fraction undefined, the denominator needs to be 0. So if I set it equal to 0, just the denominator, and now solve. So again, raise both sides to the 3rd power, get x equals 0. So at x equals 0, the original function, remember this guy over here is not the derivative, we're investigating the original function. So right there at x equals 0, we have a corner. So this is also a critical value. Max and mins, relative max and mins, can only occur at critical values. Now they don't have to, but these are the only possible spots. Absolute max and mins can occur at endpoints. Okay, so this is going to be our absolute min. This is might be the absolute max, but I'm thinking I know this is negative and this is 0, so that's the peak. So this is a relative maximum and an absolute maximum. But to verify that using calculus, we can make a first derivative table. So the first thing you do is you take your number line, the x's, and you break it up based upon endpoints in critical values. So -1, 3, 0, and 1. So I need 4 columns for those 4 values, and I put them in order. So -1, leave some space for the interval, 0, 1, 3. So I broke it up, starting here at -1, going, there's my first interval to 0, there's my second interval out to 1, and then there's my 3rd interval from 1 to 3. So I can label those using interval notation. Now the derivative tells me about direction. Positive slope increasing, negative slope decreasing. Slope equal to 0, horizontal tangent line. So let's see. At -1, I don't know the value of the derivative. I could find it out, plug it in, but I don't really need it. All right, now between -1 and 0, pick a number and plug it in to the derivative. All right, so if I take, let's see, -0.5, and I plug it in here. Okay, and I do all of this. Use your calculator. You know, if you wanted to, you could actually go like this. Do it all at once. Go to y equals, type in the derivative. So, let's see, I'll use that guy right there. 2 minus 2x raised to the -1/3. Now go to your table, set. I'm going to start at -1. And I'm going to count by 0.5s so I can get some numbers in between here. And then go to my table and I look, okay, between -1 and 0, in this interval here, -1 and 0, I get a positive number. Okay, so the derivative for all those must be positive. Matches my slope. So algebra justification for that guy. Right. Now at 0, the derivative is undefined. Put a u in there. Now the reason I know that is not from the graph, it's from what I did over here. Now between 0 and 1, I get a negative number at 0.5, so they all must be negative. At 1, the derivative had a value of 0. From 1 to 3, notice all these numbers are positive. And then at 3, I don't really know. I mean, I can look. It's positive. Doesn't hurt to put it in. Go back to -1. That's also positive. So I don't really care about the value. I just care about the sign. Now the sign of the derivative will tell you about the direction of the function.